So we are going to run the code we have seen for the custom vision. Along with that, I'll be showing you a couple of Python tricks to look at the documentation indirectly. So stay focused. So it is a trick in Python or in the debugger, which can be used anywhere you want, not just here. Most of the SDKs has this kind of tricks which you can use to find out or discover what is inside the SDK. So we have seen this images. So these are the images we are going to use. So there are two tags we will be using. One is Hemlock. So these are the images of Hemlock. So this is how it looks. Very similar images of Hemlock. And this is the Japanese cherry. This is by default available with the sample. That's why we are using this. You can try with different images, but try to use some similar images so that the model can learn correctly. If you use too many different images, it may get confused or hallucinated. So only two tags. One is Hemlock and Japanese cherry. And this is our test image, which is a Hemlock image. We have seen this, and that's what we are going to build and upload into the project. So back to our code. So this is our code and these are the endpoints. We have seen all this. So one of the things we have not seen is this part of the code. We didn't look at this part of the code. So we'll look at a little bit of this detail in this particular lesson, not really related to AI, but in general, how to deal with some of these objects. So what we can do is we can put a breakpoint right here and start the execution. So like I mentioned before, each endpoint, so this is an endpoint or a model or an instance of a model. So that is what this particular endpoint is all about. And each endpoint can have multiple projects. So different training iterations, and each project within the model. So this is the model. This is the object we are getting from the endpoint, which is the trainer object. And inside the trainer object, we have different projects, and each project has different iterations. So these iterations or iterations basically is a set of images to be trained. So that's what this is all about. So this is a loop we are going to execute here to delete all the projects and all the iterations of that project. Basically cleaning up that endpoint from all the previous trainings. That's what this code is there. Now, the code itself looks pretty straightforward. Enumerating all the projects, then the iterations in all the projects and deleting, unpublishing each of the iteration in all the projects and deleting the projects one by one. Pretty straightforward that way. There was a need for exception handling, but I didn't do any of it. This can be done from the AI Studio or the Azure Custom Vision Studio. We'll see that in the end of the lesson, but for the time being, we are deleting the projects which is created in the previous iteration or the previous execution. Now, what I wanted to discuss here is this code, this piece of the code is not part of the sample, not part of the original code written by Microsoft. This is something, this 5 or 6 line is written by me. And the thing I wanted to explain here is the way I have written that particular piece of code, which you're seeing right here. So this is very generic thing, which I'm going to explain, which is applicable for almost all this kind of scenarios when you have an SDK object and you want to do something with that SDK object. So basically, when I try to execute this part of the code, I got an error. That's where I started to write this piece of the code, right? I got an error. The error was saying I have more than 2 projects within a endpoint. So this endpoint, one endpoint can have 2 projects, not more than that, which means that it had already 2 projects, which means that I have executed this code without these lines more than 2 times, which means it created 2 projects. Remember, we are creating projects with random name here. The project name is a UUID, which is randomly created. So every time the project gets a new name. That's what this particular line is all about. So I had to write some code to delete the previous projects. So now I wanted to know all these API names. So trainer.getProject, trainer.getIterations, trainer.unpublished iterations. So the first thing I started to try is looking at the documentation. And unfortunately, the documentation was not very easy to find, at least the point in time which I searched for it. What is the next thing I can do? I'm sure if I search enough, I may get the documentation eventually. But one of the things I did was using the watch window in the debugger. So what I did was I added the trainer object to the watch window. And one of the fields we've been ignoring so far is the function variable. So this variable we used to ignore so far. In fact, all these variables we used to ignore. They are pretty useful and it tells a lot about the actual object, but that's for another time. Now the function variable will tell you what are the function exported by that object. These are the different function implemented by that particular object. Now, what are the arguments to pass? Can we get a hint of any of those arguments? So let's take the example of get projects. So we have get project and then get projects. In this case, we need all the projects. So we are going to call get projects in this case. And in the metadata of that particular function object, we can see the URL /projects. And this is a clean hint towards the API calls behind the scenes. So basically, this is the endpoint or the API which this particular function will call. So it doesn't have any arguments. It is just calling /projects. And when we call this thing right here, it doesn't take any arguments. Now, let's take the example of get iterations. So get iterations. To see the get iteration, we need a project ID. So let's see that. It's again in trainer object, get iteration. As you can see here also in the metadata, you can see the project ID and the iteration ID. So this is get iteration. We need get iterations. This is the get iterations. It should take only one, which is the project ID. So the one thing inside the curly braces, it's an argument to the API. So this is normally how a REST API is argumented if it is a URL parameter. Not always things are URL parameters, but in this case it is. But ultimately the idea is this object has certain functions it exports, which is available inside the function variable, which you can use to call it. Sometimes the arguments are clear like this, not always, but in this case it was pretty clear and we used it like this. I got a bit of errors here and there, but without any documentation, just looking at function variables, I was able to write this piece of the code. And unfortunately, I don't know if you have done it already, none of the LLMs, all this ChatGPT cloud, all this code writing things will not write any correct code for any of this kind of things. You can try it yourself, but these SDKs are very kind of private to Microsoft, or the LLMs are not trained to code in this. You can try any LLM. At least at this point in time while I'm talking, I have tried Cloud, I have tried ChatGPT, I have tried GitHub Copilot, everything to write this 5-6 lines of code. None of them got it right. I had to write it myself using this method I'm talking to you, using function variables and this URL parameter. Probably by the time you watch this video, the documentations are better, LLMs are better. Let's hope so. But for the time being, this is what I did. Now, before we go, let's look at unpublish iteration as well. Unpublish iteration, just one more example. Feel free to look at other methods. Call those methods if you want. I have not explored everything. But as you can see here itself, you can see the metadata, the project ID and the iteration ID. That's what we need for unpublish iteration. This is a publish iteration, so we need the unpublish. Anyway, you have already seen that. Here we go. This is the unpublish iteration. As you can see, it is taking 2 arguments. And that's what we are passing here. So like I mentioned, the arguments are not always clear from the function variables here, but it's almost always clear the function names, which is a great thing to have. So that is all about this lines of code. It deletes all the previous projects, images, training data, everything, and cleans up the endpoint. That's what it is going to do. Let's see if it works. So I'm just going through each line. If you want, you can look at each object. It has cleaned up everything. Feel free to debug this code more, but pretty much straightforward. The project ID is nothing but a GUID. That is one thing I want to mention here. This is the GUID. We'll see that shortly. Now we are creating a project. We have seen all this code. So we are creating a project and the project name is this. It's a GUID and this is the value of the GUID. At the end of the day, it's a pretty big number. It's a 128-bit hex number. That's what a GUID normally is. And we have created the project successfully. And this is the ID of the project. It is the same GUID. Right now it is a string and the object is of the project type. Now we are creating the tag. 2 tags we are creating, hemlock and Japanese cherry. So they themselves have some IDs and stuff. Have a look if you like. Always have a look at the object and look at the parameters inside them to understand more about the nature of that object. So base image location, this is just not really an object, it's just a string. This is where the images are going to be. So this code is just creating that location. If you want, you can hard code this. It's not a very complicated thing, although it is looking too much nesting and things like that. So if you want to dig further into this, feel free to print each and every thing. For example, this __ file __. Those are things which I'm not discussing because it's not really related to what the topic we are discussing. It's just the path of the file. So print all these things individually or put it in the watch so that you can understand each of this thing, what it returns. Otherwise, it is just the path of the image for the time being. So image list empty array we have created, and then we are appending one image at a time. So that's what we are going to do. So we have total 10 images. I'm going to put a breakpoint here. After that, the image list will contain both the hemlock and Japanese cherry with the corresponding tag right here. So I'm going to step through that whole thing. So we have the image list created. So this is the image list. Total 20 images are there, 10 for hemlock and 10 for Japanese cherry. So total 20 images. Now again, we are calling an API. So this particular API we are calling create image from files. What are the things we are passing? The project ID and this image list we have created. Image file create batch. So that may take a couple of minutes, depends on the size of the image and things like that. Right now it is processing and the processing is done. Let's see if it is successful. It is successful. That's why the upload result is batch successful equal to true, which means the thing is successful. So that's what we are checking here. If not upload result. Like I mentioned in my previous training, I'm not really a fan of writing code like this. It's not very Englishy looking. I prefer to write if true not equal to or something like that so that it is more readable. But at the end of the day, this is all about if upload _ result is batch successful not equal to true. That's how it is read correctly. Then all this error handling get executed. But in our case, it is successful and we are continuing with rest of the code. Now the training starts. This is the most lengthy part of the execution. Probably I may have to cut the video, and the training already started after calling this API. Now what we are going to do is that we are going to do a wait for the status to be completed. So that's what we are going to do. What I'm going to do is I'm going to put a breakpoint here and press this button, continue, so that I don't want to wait too much and step through everything. So that's what is happening, waiting for 10 seconds. The training is going on. Normally training is a very expensive and lengthy operation as far as artificial intelligence is concerned. A lot of compute is needed, a lot of processing is needed, a lot of data is needed. In our case, we are not training with much data, but we are simply creating a couple of images at the end of the day. So the training has finished and it took around 15 minutes, 10 to 15 minutes to complete the training. Now we need to publish the iteration, pretty much what we have trained, we need to publish. And once we have done that, it will come in the other endpoint, the prediction endpoint after the stage, and we have successfully published. In the publish, the argument we are passing is the project ID, iteration ID, and then this one particular string we have created in the start, and one more string which is the prediction resource ID. It's all variables we have been creating. It's all here in the beginning. To make this sample work correctly, you need to change all these numbers and endpoints and keys and everything. So have a look at the string to understand more about it. For example, it has your subscription ID of your Azure subscription. Then you have your resource group and things like that. This is the name of the endpoint. So coming back to the point we were, so we have published the iteration or the trained data. Now we can use it. That's what we are going to use. We are going to create a prediction endpoint. So we are using our key and endpoint, create the predictor. If you want, you can have a look at the functions exported by this prediction endpoint. So detect image URL, a couple of things are there. You can have a look. Classify image, that's what we will use. Then classify image using the URL. Almost all the classify or analyze image has URL options, just like we discussed before. And in this case, we are opening up that hemlock image. In that folder, we have seen that, and we are trying to classify it. And we are waiting for the result. We got the result. The result took a couple of seconds. And again, in this case, we will be focusing on the objects which are not underscore. So let me close this and add this result to the watch window so that we can look into it. So this is the result we got. So if you want, you can look at these additional things. We'll be focusing on prediction. So we have 2 items in that particular object. And with a probability or a confidence of 99.99, which is almost 100%, that it is hemlock. So it is almost sure that that image is hemlock. In fact, that image is indeed hemlock. So pretty sure about that. And probability of 3.27, I think it is 10 raised to minus 7. It's a very small number. It is saying that it is Japanese cherry. This is a very small number. This is minus 7, if I'm not wrong. E raised to minus 7. It's a very small number. That's all we need to know right here. So it is almost sure that the image is hemlock. So from that, the training worked correctly. Try with different images and you should be able to get some different results as well. So make sure that you use similar images like the one we have seen. Try to use more number of images so that the model can really learn. This may not really work for face detection. So face detection is totally different. So this is normal computer vision, just the custom computer vision, not for face detection. So now we are printing the result and we got this printed. So we have seen how the code is behaving. Now let's look at the Vision Studio. There is something called Vision Studio. That's what we are going to look at next. And after that, we'll be looking at object detection.